Hello, everyone. Welcome to our DA panel. So we will have top DA projects founders are all here. So from the very beginning, I will let everyone introduce yourself, the project you're building, and decide the DA solutions that you're working on. Yeah. Starting from you, Mike.
Hey everyone, I'm Michael, the founder of Zero G or Zero Gravity. We are the first modular AI chain, and we help launch AI D apps in the fastest DA possible, and we'll chat about that.
Hello. Hey guys, I'm Ganesh Swami. I'm one of the co-founders of Covalent. We are the largest indexer in the space. We have scraped about 200 blockchains, normalized that to a canonical schema, and offer that through an API. And excited to share my views on DA.
Hi everyone. I guess I was just here, but I'll reintroduce myself if you're kind of streaming in or you didn't hear me introduce myself before. I'm John, one of the co-founders of Celestia. I do research protocol specification at Celestia Labs. Celestia is the first modular blockchain network and kind of the first blockchain to be built specifically for scalable data availability.
Hi everyone, my name is Dan Mills. I'm head of product at Avail. Avail is an infrastructure layer for helping modular execution layers scale and interoperate. And our first product that we're launching is a DA layer going to mainnet pretty soon.
Hi everybody, I'm Sreeram, founder of EigenLayer. We are also building a product called EigenDA, which is a scalable data availability system for Ethereum.
Thank you. So for the very questions, I would like to ask, for a general question for DA compared to the internet. We all know that the internet's increased capacity has led to new concepts like streaming, VR, and remote working. And we are all waiting for a pivotal moment for blockchain, let's say the YouTube moment for blockchain. Over the next 2 years, where do you see the most promising potentials in the application space with hyperscale DA solutions?
Yeah, actually, that's why we exist specifically. So we made a few really exciting announcements this week. So we're the first to introduce infinitely scalable DA, dedicated DA, and also aggregated DA. So each one of our consensus layers does about 50 gigabytes per second, and we can then infinitely scale that horizontally. And so with that, you can finally build things like on-chain AI, on-chain gaming, high-frequency DeFi applications that you couldn't before. So to give you a sense, so regular kind of DA layers that cost anywhere from $3,000 to $13,000 per gigabyte per month. Ours will cost about $50, which basically then puts it into the category of Amazon S3. So you can then finally, have very large data pipes and build some really exciting applications on space. And so that's where I see the future going. I basically see that every company will become an AI company in the future. And so we in Web3 need to keep up with that. And so that's why we're building what we're building.
I'm going to take a different take here. If you look at how the internet evolved on the application layer, the first generation applications on the internet were mostly replicas of existing businesses. This is like online banking and web stores and so on. The truly internet native business model started almost 2 decades after the internet became mainstream. This would be something like Airbnb, things like Uber, which were not possible in an offline world. So I think with crypto, it's going to be kind of something similar. Most of what we see today are replicas of existing businesses, lending business models and dexes and so on. The true internet stuff, I think we haven't seen what is possible. So I'm excited for, we have lots of geniuses on this stage, excluding me. And so some of the stuff that they're building, the infrastructure that they're building is going to be transformative when it comes to applications.
Okay, I guess I'll also go with a contrarian take, which is that I get 2 facets of my opinion here, which is just my opinion loosely held. The first one is that I'm of the opinion that for new applications that don't exist currently, there's a good chance that the next kind of application that really takes off, that's new, isn't going to be foreseen. or like it won't be obvious until it happens. And after it happens, they'll be like, oh, it's obviously that could have been the case, but like it'll just kind of come out of nowhere. That's my opinion. The things that are predictable are the things that I think sure they could do well and stuff, but I think the thing that people are like really gonna get excited about, the new paradigm, is going to come out of nowhere. So that's one facet of it. The other facet is that I think with scalable blockchains and scalable data availability layers in general, I think the important thing is they don't just unlock new applications, but they also unlock being able to use existing applications better. And this is important because a lot of existing applications aren't actually good enough in the current, or I guess pre-launch of Celestia, state of the blockchain ecosystem. One of them being something as simple as payments. Right? You try to use Bitcoin for payments, not great. You try to use Ethereum for payments. I don't know if you tried to use Ethereum for payments in the past week. There's like several dollars to just send some USDC somewhere, right? So the payment application is the one that everyone has said, this is something blockchains are uniquely very suited for. They're very good at this, but they haven't kind of taken off in popular use because they're just, as soon as they get used at any reasonable amount, they just get super expensive. So finally, we're finally at kind of a juncture point in the blockchain evolution with the launch of scalable data layers, that something as simple as the very first applications blockchains were built for, payments, I think, can finally hit mainstream adoption.
Yeah, if you take a step back and look at the evolution of hit applications, must-have applications on other mediums, like on phones, for example, I agree that they didn't happen from day one, and they usually require multiple things to come together for it to be a truly innovative hit application. Like if you think of, for example, like when did Uber come out? Uber came out many years after the introduction of cell phones, years after the introduction of smartphones even, and it was because there had to be enough mass adoption. Phones had to be good enough, computation-wise, for example. They had to have GPSs built in. Somebody had to kind of connect all the dots of, there are enough people, they have GPSs built in, networking is good enough, and then suddenly, somebody can come up with that use case. Even something like YouTube, for example, that was part of the question, same thing, like YouTube came in many years after the introduction of the internet, right? It takes many things to come together and for frameworks and systems to come to maturity for somebody to be able to innovate and come up with a hit application. And even today, on a mature platform like a phone, there's like hundreds or thousands of applications released every day, but it's only one in every 100,000 or one in every million that is actually hit application. And so I think in the context of blockchains, and especially from our context here as infrastructure people, what we're looking to do, in my opinion, is to make a huge playing field for people to start to be able to experiment and innovate and create all kinds of applications on blockchains. And so I think that's where DA is a big unlocking technology, because it enables execution layers to be created very easily. As we were just seeing, from John's presentation previously, there's like rollup as a service providers that are making it super easy to deploy rollups. I think that's going to be the norm for how to deploy applications. We'll have thousands of applications deployed as rollups. And so I'm really excited about the ability to then combine all those rollups and have them work together in unison to solve user needs, which is why that's one of our focus areas, is to try to figure out how to, we have a Nexus layer where we combine, we do proof aggregation and we do data aggregation at the DA layer, and we allow for these unified user experiences. So I think enabling innovation, like increasing the rate of innovation, is how we're going to get to hit applications. I don't exactly know what they will be, but they can't happen with today's blockchains. We need this new technology to take hold.
When you think about applications, any application that can be built on a blockchain can be built without a blockchain. That's just the obvious thing. Any application that can be built on a blockchain can be built without a blockchain. It just doesn't have the same rigidity. What is rigidity? You know, whether it's user verifiability, mutability, censorship resistance, all these properties. So another way of phrasing the question is, which of these properties is going to be so paramount and so important and so interesting that application developers are going to use it in ways that they couldn't do before? And our view is this comes from permissionless innovation. So imagine you're a developer and you're building an application on top of Twitter. You're relying on the Twitter APIs. Not only that, the Twitter APIs give you the right answer, which they usually will. So safety, correctness is not usually the way in which these systems equivocate. They usually equivocate by shutting off the API. Censorship resistance. Censorship is basically the unilateral ability of the one person with the root node to actually control who can and cannot build on top of the system. And this is the major unlock of crypto, is censorship resistance for developers. And another way of thinking about it is it's real property rights for developers. When I'm going and building something, imagine I want to build a store on top of this building. If this building had like root control, that they can change the building, they can throw me out whichever day, then I have no rigid property rights to build and invest some really good store on top of this building. But if I had rigid property rights, then I would actually be able to do it. That's the same thing that's happening to developers today. If you're building an application on the cloud, you are reliant on a lot of other parties, not because the cloud, AWS is going to suddenly like throw you out, but you're going to rely on other people's frameworks like Twitter or Facebook or somebody else to give you access, and they will give you access till it's convenient to them. And this creates very fragile ground on top of which you're standing. And the core point of like crypto to us is to be the coordination layer for open innovation, enabling many, many people to build features and stuff on top of each other. So that's the place where I expect to see the maximum interesting things happen, whether it's in permissionless world building in games, or like social, where other people can build features composably on top of each other, or more open structures where, when you have a network, you can have different kinds of recommendation systems and other things. When you have AI, you can have customized and fine-tuned AI applications built on top of each other. So our model here is that the developers and composable development comes first. As a consequence come users. So that's our view here.
Fantastic. Next, I will give questions for everyone. So starting from you, Michael. We know zero gravity is a rising star in the DA space. Before you started this project, multiple DA solution initiatives were already in place. Why were you determined to launch zero gravity as a new initiative? What aspects of the current DA solutions do you believe can be optimized and scaled further?
Yeah, the reason we started wasn't to build a DA layer, but that's a really key component for hyperscaling kind of AI applications. Our mission is essentially to make AI a public good. And it's only a matter of time, let's say 5, 10, 15 years, whatever it takes, before you start seeing a lot of automation happen. AI running administrative systems, AI running production systems, AI running transportation systems. Do you want to live in a world where the AI can cheat, especially if it has superhuman capabilities? Imagine ChatGPT 10 comes out, for example. Like, who's super aligning that particular AI agent? In a blockchain environment, the AI can't cheat. So I really agree with Sreeram. Censorship resistance is super key to this. And so that's why we really took a first principles approach and essentially said, well, what needs to be built in order to see that vision, to see that future actually happening? And so we said, the main bottleneck right now is that DA needs to be hyperscaled. And so not just an order of magnitude, but many, many orders of magnitude, infinitely scalable. So you can actually have very large data pipelines, and you can run anything that you can run in a centralized context on a blockchain as well. And so that was really the journey from a thinking perspective of how we got there.
Thanks for sharing. A few months ago, I read Sreeram's Twitter thread about the journey of EigenLayer. It began as a personal commitment to expand and optimize wireless network bandwidth. And today, EigenDA has matured into an innovative DA solution. Recently, particularly in DA solutions, we see the vision of a hyperscale blockchain becoming feasible. Reflecting on this, what insights can you share from experience of building a scaling solution, Sreeram?
When we started looking at the data availability landscape, one of the core things was the trade-off between the three dimensions. You have security, you have decentralization, and then you have scale. Can you get all three? And that was the kind of fundamental question. And already the core thing is, in many simple methods to try to scale, you have to compromise either decentralization or security. So when you try to scale in simple methods, what's a simple method? Take a data and replicate it redundantly among small groups of nodes rather than among all the nodes. Because when you're replicating across all the nodes, you lose scale. So you don't get any scaling as you get more nodes. Okay, so if you replicate it only among a small group of nodes, you're losing security because those small group of nodes now determine whether you're secure or not, rather than the entire group of nodes. So this is the basic kind of trade-off between security and scale when you scale the number of nodes. So what we wanted to do was to build a solution which simply doesn't have this trade-off. And what we were seeing was at that time, both in the Ethereum Foundation and other solutions which were coming up research papers which were coming up actually had specified this high-level idea that using erasure codes, you can actually scale. This idea of using erasure codes to actually scale data bandwidth is a very standard idea in wireless. That's how wireless systems work. You use erasure codes to actually scale. But the orders of magnitude in which you could scale when we first did the calculation was pretty stunning, that in a simply redundant coding system where everybody just you redundantly replicate the data, relative to that, if you use erasure codes, you can scale with an order of n. What is n? N is the number of nodes. And if you look at Ethereum, the number of nodes is 1 million validators, each with 32 ETH. That's an insane amount of scaling that can be unlocked if you do the erasure coding right. What we were doing is we looked at the different architectures people were building, and the thing that we were seeing is they all had single point bottlenecks which had to download all the data. And we built, we want to design an architecture which simply doesn't have that bottleneck. There is no node in EigenDA which ever touches all the data. Every node only touches a small fraction of the data, and together they all have enough portions of the data that even if a minority of the nodes misbehave, you can still reconstruct all the data. So that was the core thing in EigenDA, and the metric that we were optimizing for all the time is the same metric we used to optimize in wireless, which is throughput relative to the underlying bandwidth. So in the data availability case, the throughput is what is the rate at which you can send data, and the normalizing condition is what is the node requirements. Ethereum has this principle that you need to be able to work with very light nodes. So our node requirements were very, very light, 0.5 megabytes per second. So we fixed that as a constraint and then ask, how can we scale the system? That's really how EigenDA works.
Thank you so much, Sreeram. And for John, it's super interesting that we saw a lot of community members running Celestia light nodes on Kindle, on Switch, and this is made possible thanks to data availability sampling. In practice, how do you envision the future of hyperscaling DA solution with DAS in the coming years?
Yeah, so DAS, or data availability sampling, is kind of what gives Celestia, sure, but also any secure data availability protocol. Data availability sampling is kind of the thing that ultimately underpins the security. And it has the very nice property that, unlike traditional blockchains, which have full replication, which is something Sreeram was mentioning, where they have full replications, these kind of data availability first blockchains use erasure coding to avoid this kind of full replication, and that allow light nodes to contribute security to the network in a way that they don't in traditional blockchains. For example, you're in the Bitcoin blockchain. If you run a full node, you can be guaranteed about the integrity of the Bitcoin blockchain for yourself, but you can't prove the integrity of the Bitcoin blockchain to anyone else. They have to run their own full node. And even if you had some sort of, say, ZK meta thing to prove validity of the state transition of Bitcoin, that still wouldn't tell you whether or not Bitcoin blocks are available or not. You still have to fully download them to guarantee their availability. So that's where data availability sampling comes in. It allows you to have nodes, these light nodes, that don't have to fully download the data, but they are basically as secure as full nodes. Like, there's only very tiny difference in their security assumptions, and most importantly, they also contribute back security to the network, because the whole network working together can reconstruct blocks that from samples. This was kind of like a more technical thing, but this is very powerful because it allows you to have much larger block sizes than you would have in any traditional blockchain. And we're not talking about one order of magnitude or two, but we're talking about there's many zeros there. The order of magnitude difference in throughput that you can get is astronomical. And I think I'm very excited for seeing a future where protocols using data availability sampling allow for scalable data layers, which can you can then build settlement execution layers, etc. on top of. Did that answer your question?
Yeah, exactly. Thank you, John. And for Ganesh, we know Covalent has been building data solutions for the whole ecosystem for quite a few years. Could you share more details for the DA solution that you guys are currently building? And how does it play a role in your existing tech stack? Any interesting point of view that you would like to share based on your experiences in the data space?
Sure, thanks. A few years for sure. I'm looking at that picture of my face there, and I'm just a lot younger there. I wish has been a few years and a few cycles. So one of the fundamental misconceptions about blockchains is that people think of blockchains as databases, but it's more like billboards, which means you post data on there, get it done, and then you eject it. That's the whole point of blockchains. And when we started Covalent a couple of years ago, blockchains were holding entire state, right? There were no light clients. There was none of this technology. And as these nodes became heavier and heavier, it kind of goes back to that trilemma and reduced the decentralization aspect, because only professional validators and exchanges and custodians were able to run these full nodes, which goes against the ethos of the entire space. So nodes started to become specialized. And what has happened over the last couple of years, coming with the most recent mainnet Decon upgrade, is that access to historical data is starting to become a challenge. So let's look at what's happening here. So the rollups are posting data to call data, and they're now moving away from call data into, in the future, in a couple of weeks, into blob storage, which has a different gas market. And these blobs are then deleted, so that data is not available. If you happen to use a DA layer, like one of these excellent solutions here with Celestia, EigenDA, or Avail, after the challenge window, that data is deleted. With the full sharding, what happens is that even if you were to run a node, because of, I think a similar concept like erasure coding, the transactions in a block is not within your node. So there's a problem with accessing data. So essentially, this thesis of blockchains being billboards and not databases is coming through. So you need a database that sits besides the blockchain, and that's what Covalent has become, has evolved to. And then we have these downstream products, but that's on the application stack. So that's the first key point. The second key point is, if you study it's a good example here. So sparkling wine and champagne, you can only call it champagne if it comes from the Champagne region. Otherwise, it's sparkling wine. And I think at some point, the consumers of the data are going to ask for secure data that may not have the same security properties of the L1, but definitely gone through a cryptographic security check. And so that is what we're building with the Covalent, the proof and the commits into all of the transmissions and all the steps that have gone into mutating this data. So data is of different forms, and then people who want the full security will pay for that data. So some things like game state probably doesn't matter as much, but some things like financial records, it definitely matters a lot. So that's fundamentally our belief about the space.
Thank you. And for them, we know Avail provide not just DA solution, but also interoperability layer via Nexus and also fusion security. Dan, could you share more details about each component and the potential synergies among them in Avail's tech stack?
Sure. If you think about this huge explosion of rollups that we've been talking about, which has already started, and we think what we've seen so far is just the tip of the iceberg. There's tons more rollups to come. A clear problem that emerges from that is fragmentation. So if any of you have ever tried to transfer an asset from one L2 to another L2, you've experienced this. If you try to build an application that uses 2 chains at once, it's a nightmare, basically. And so this is only going to get worse, right? More and more rollups make that worse. So we're solving the scalability problem, but there's this other issue that's created by many rollups that a pure monolithic approach wouldn't have. And so what we're doing is we're building what we call the Nexus, which is it's a couple things. It's a proof aggregation layer that sits on top of Avail DA, and it leverages Avail DA to do data aggregation. So we're relaying chain information into Avail DA so that we can be sure about the order of transactions. And so it's that combination of having DA for the chain data plus the ability to check the execution of all of these chains that then allows the ability for any rollup to know the state of any other rollup in the system without actually running a full node of the other rollup. And so what that translates to is a seamless user experience where each chain is still modular. They can still iterate on their own. They can be sovereign or not. They're independent. They build independently, but we can work together. And so that's the kind of user developer experience that we're looking to provide. And if you think of what that means is that it's relying on Avail DA to provide highly trusted data for the data availability function. And so what that needs is a lot of crypto economic security at that layer. And so that's what Fusion Security is aiming to provide. So Fusion Security is a way to bring tokens, especially high-value tokens like BTC and ETH, over to the Avail DA network and use them as part of the consensus of the Avail network. And so with that, we are hoping to really increase the amount of liquidity and crypto economic security at that layer to provide further security.
Thank you, Dan. I've got a general questions for everyone. So over the past 3 years, we've made significant progress in Ethereum scaling. And what kind of scalability multipliers are we currently considering, such as DA, proven systems, verification layer, and the others? Have we already reached our scalability goals, or are we still some distance away? Starting from Sreeram and getting back to Michael.
Yeah, the really cool thing with the existing techniques for scaling is that they can theoretically allow for infinite scale. So the idea is that as you have more and more nodes, the total bandwidth, for example, that a DA system can support linearly scales in the total amount of bandwidth aggregated across all the nodes. So theoretically, there is no gap between like a Web 2 and a Web 3 system. That gives me a lot of encouragement that potentially as we build these engineering solutions going forward, we will close the gap. And since there's no penalty for decentralization, you can actually build super scalable systems. I just want to give a shout out to the, both John and Dan here mentioned about data availability sampling via an analogy. Imagine you have a commons, okay? The blockchains is our commons, many people here mentioned that we want to build public goods, right? So blockchains is our commons, and when you have a commons, you have this problem of monitoring the commons, okay? Imagine you have a fishery problem in a village. You have a pond and there's a lot of fish, and you want to make sure that people don't overfish. And the problem is that if somebody goes and overfishes, then basically you are left with a non-sustainable resource there, because that resource is depleted. So this problem of governing the commons, people have thought about a lot, and one of the things that helps a lot in governing the commons is to lower the monitoring cost of the commons. Can you come up with a simple solution where many people are watching the commons, the common resource, the fish in the lake, and make sure that nobody overfishes? How do you do things like this? And I think what we've seen is, with the emergence of like blockchains and the massive amount of information technology, the communication bandwidth that we have with our phones today, we can actually create a global digital commons, these blockchains that can be monitored with very low overhead. That's what data availability sampling and zero knowledge proofs do. And this is such an insane breakthrough that, we can have global commons which are monitored by everybody running on their phones. This is going to change a lot of things in the coming decades. All kinds of property rights will be encoded, all kinds of systems of ownership. For example, Michael talked about AI models. Who owns these AI models? How do we ensure that other people can continue building on these AI models? All of these rights will be encoded in these commons that can then be monitored in a scalable manner. So I'm actually quite optimistic on the amount of scale that we can achieve here, while preserving the rigid coordination conditions that we need to actually make these systems work.
Yeah, to add to that, and to go back to your question about EIP 4844 in particular, I just wanted to point out that I think that the demand for blockchain space, block space, is huge, and there's a lot of latent demand out there. As we were just discussing, that we have these like very easy to deploy rollups. We're gonna have probably hundreds of thousands of them at some point. The 4844 is, I think, a huge improvement over the status quo, and a big win for the Ethereum team to get there. But there's still quite a ways to go for like the full dank sharding plan. And I think there's tons of demand, more demand that what 4844 can provide. Yeah, I just wanted to point out that from the point of view of like the off-chain DA solution, we have implemented a lot of the technology that goes into full dank sharding. We have KZG polynomial commitments. We have DAS, data availability sampling, with a validity proof approach. For chains that build on Avail, they can already make use of this technology today, basically. For chains that still want to settle on Ethereum, that is absolutely possible still via, we have a ZK bridge that allows chains to be validiums, for example, and make use of block space outside of Ethereum but still settle on Ethereum. And so I think these technologies really drastically increase the total throughput of the Ethereum ecosystem as a whole. So I think it's, I don't think we're there. Like, I think there's more to do, both within the Ethereum ecosystem, within Ethereum proper, and within the ecosystem in general. But we're well on our way. There's already, I think, huge opportunity for using all of the solutions that we have here.
Yeah, so I guess to echo what Sreeram said, in terms of the theoretical output of these, there's no bound with protocols like with schemes like data availability sampling, and I think we're kind of in terms of basis layer scaling, I think we're finally at a juncture in the blockchain evolution cycle, at least as far as we can tell, that a lot of the open research problems have kind of been resolved, at least for the next several orders of magnitude. For instance, the Avail team has implemented KZG commitments and data availability sampling over that, which is what has been something that people have been researching for years now. It's finally implemented. right? Celestia being the first blockchain to have data availability sampling in production, which again is something that people had been talking about for like half a decade or more. So in terms of like the research problems, I think those are kind of resolved, at least for the foreseeable future. What isn't resolved is kind of implementing everything to be able to get to that boundless scalability, because there's always so many implementation bottlenecks that prevent you from actually reaching what is theoretically possible. And in terms of that, have we hit the limit on that? The answer is like no, not even close. There's so much that can be done on the implementation side to get so many more zeros that like it's not even funny how much engineering work that's going to take, but it's also not funny how much more scale that's going to give us. In terms of, I mean, I guess we're talking about hyperscale DA, but like in terms of if we're also going to go on the parallel execution meme, right? There's also things on top of the DA that also need to be resolved, and that's kind of a different problem that we aren't really working on. But the execution over the hyperscale DA, that doesn't have the same scaling properties as data availability sampling, and that's kind of where there's still research being done on things like parallel transaction processing schemes, stuff like that. But that one is still open research. But that's a good thing because the research is fun.
So if the question is the job done? And the answer is no. I think we're just getting started. So what our peers here have demonstrated is really technical innovation. So rollups haven't really solved the problem of using block space because this leads to congestion when you're posting the data back to the L1. That's why L2s continue to be expensive. So things like changing the scaling factor to n, where n is the number of nodes, is a brilliant innovation. To the DAS schemes that scales the validation. These are all technical innovations, but I think there's still a lot of governance and economic innovations still left to be understood. Economic scaling and governance scaling. So how do you get a lot of people access to the things that blockchains enable? I think $1 per transaction is still very expensive. I think we should have orders of magnitude in terms of economic scaling. I hope these technical solutions enable economic scaling in some ways, so it gets more people, it gets blockchain technology in the hands of more people, so that would be an amazing thing to do. And the governance, again, I think the entropy of these systems leads to centralization, just power laws, just like economies of scale. And I think there's a lot more we need to do to scale the governance aspect of these things so it continues to remain decentralized. So I would say a concise answer is the answer is no.
Yeah, I'll add a little bit to kind of the thought process around this as well. But first of all, definitely agree with what Sreeram said. There's no difference in terms of what can be built from an infinitely scalable perspective between centralized and decentralized systems. The first thought I'd add that on the execution layer, we're now getting on very much on par with Web 2. You start having some interesting projects like Monad, for example, or Fuel, building like parallel VMs that can push through a lot of transactions per second. And with that, that's kind of like, if you use an analogy, that's like having an ultra-fast CPU. But then if you have really slow RAM, then your system still doesn't work very well together. And so that's really the point of data availability. And so what we've essentially figured out is that, yes, we can use KZG commits and we can use data availability sampling, but that data availability sampling is done by a consensus network. And then we have a separate decentralized storage network. And then we figured out that you can actually infinitely scale or horizontally scale the consensus layers. So then you get an infinitely scalable DA solution. So the solution is already here. We are basically implementing that by hopefully the end of the year. And so, yes, we've reached the basic limit in terms of what you can do with a DA solution. But then the final thought I'd add to that is, let's take a step back and think about it a little bit more philosophically. What does it mean to have hyperscale in the future? There's a hardware and a software component to that. The hardware component is that we have Moore's law and we've got lots of things growing very quickly. So your smartphone in 10 years is probably going to be significantly more powerful than even servers in a server room. And so that hardware then enables completely new solutions as well. So that's one aspect. And then the other aspect is, what does the end game look like? If we think about what is data that we can store, let's say from the beginning of the universe all the way till now, every interaction with any object that's ever happened, can we store that in some ledger or database today? The answer is no, because the hardware isn't available yet. There's some teams that are working on, for example, using DNA storage to put into like an infinitesimally small cube what an entire huge data center can store today. And so those types of solutions are going to come online. Solutions like quantum computing are going to come online. What is that going to enable us? So if we have this like huge data set from the beginning of time until now, how do you even run compute on such a large data set? You need that type of hardware to also make a difference. So those types of things haven't been solved, but infinite DA essentially has been solved.
Thank you, Michael. All right, I guess that's the order of this panel. Thank you, everyone. Thanks for your incredible views.
Thanks, everyone.